So let us see another phenomena, that is runtime polymorphism, which is based on method overriding. So I have a class A1. I'll declare a method show. In show of A1, I declare another class B1, extends A1, again show, then we have another class C1, again extends A1. So we have two subclasses of A1 and both override the show method. So in effect we have three classes: A1, which is a subclass, B1, which extends A1, then C1 extends A1, and now we'll see what is runtime polymorphism. So all classes carry a method show with different implementations. So I have A1, A is equal to new A1, B1, B is equal to new B1, C1, C is equal to new C1. So I have objects of all the three classes. Now let us see what happens when I say A dot show. It calls show of A. If I say B dot show, it calls show of B. If I say C dot show, it calls show of C. So there is no magic here. As regular, A dot show, B dot show, C dot show. I'll just run and see the output. We have show of A1, B1 and C1. Now this is where the magic starts. Now as we had seen in the last lecture, casting of objects, then the object of superclass or variable, it can refer to the subclass object. So I say A1 equal to B1. Oh, sorry, the object is A and B. So A is an object of superclass A1 and B is an object of subclass which is B1. So I am passing the object of subclass to the superclass, and now I write A dot show. So what happens now? Just write magic starts here. So let's see what is the output here. When we call A dot show, after passing the subclass object to the superclass, the show called is from the class B. This is because B is the active object in this case, and because B has its own show, so this show will be called from B rather than A. So this is what we refer to as runtime polymorphism. Now why polymorphism? Because now if I pass the object C to A and call A dot show and run this, so I get in show of C1. So depending upon the type of object we pass to A, this A calls show from that class. So this same statement A dot show, it is giving different result here, depending on the type of object that we pass to A. So this is what we call as runtime polymorphism, because the type of object that we pass to A we can determine only at runtime, and system at compile time has no idea as to what object is carried by the object A. So we'll just go through it. So this is what is happening. So this runtime polymorphism is applicable only to overridden methods, as we have in class A1 we have a show, in class B1 we have a show, in class C1 we have a show. So whatever object we pass to the superclass, that is A, that very the body of that very class method will be run by the system. So in case I refer A to object B, then this show will be called from the B class. In case I pass object C to A, which is from class C1, we'll have show running from the class C. Now even I need not even create an object of class A. I can even use a reference of class A. The only thing is I cannot call directly the show of class A, but we are not even interested in seeing this thing. We are more interested in seeing what happens when we pass the objects of subclass to the superclass. So in effect we have that superclass variable or object. Either you can use the superclass reference or you can use the superclass object can refer to the subclass object. So when it does, the superclass variable, it runs the overridden method from the subclass. So A equal to C, and then A dot show will give you an output which comes from C. A equal to B and A dot show will give you an output which comes from B. So this is what is runtime polymorphism. So let us see what happens if I make this method as private. Now I have made the method private in class A1, and let us run the method again. So now what happens is, there is no magic. We have in show of A1, in show of A1. This is because only this runtime polymorphism, it only applies to overridden methods, but private method is never overridden. This is because it is never visible in class B1, so it is never overridden. So this will always give you show of A1 from the superclass. So in case of private methods, no runtime polymorphism phenomena occurs, and it will always give you the show output from the type of object that A represent. If A belongs to A1, so you will always get the output of show from the A1 class. Secondly, I just put down the rules that we have for polymorphism. Runtime polymorphism, rule number 1 is that it does not apply to private methods, or in other words we can say private methods are never overridden. So when they are not overridden, they cannot display the behavior of runtime polymorphism. Second, let us make all methods in this system as static. So all methods are now static, and we again try to see the output. So it is exactly the same output that we had got for private methods. This is because static methods are bound to the class rather than the object, and this runtime polymorphism, it depends entirely on the type of object, and we know static, they are independent of the type of object, so they don't show the behavior of runtime polymorphism. So as we have already seen, in case of static methods, they are never overridden, and A dot show will always call show from the class to which A belongs. So even in this case, even though A is referring to an object from class C, the show is being called from class A. So rule number 2 is static methods are not overridden. Now third, let us see what happens in the case of variables. If we have variables which are similar in every class, I have an x in A1, I have a x in B1, I have a x in C1. So now I have A1. Now A is equal to B, and I print A dot X. And then I say A equal to C, and I have print A dot X again. So the same thing that I did with method, I am now doing it with variables. So let us see the output here. So we have after passing B we get 10, after passing C we again get 10. Now 10 is what is the value declared in class A1. So we see that there is no such runtime polymorphism that applies to variables. This is because variables are more tightly bound to the class as compared to methods. So there is no runtime polymorphism in case of variables. So I have no runtime polymorphism in case of variables. So another thing is, as we had already seen that we cannot have different return types for methods which override, but suppose I say here that this method returns A1, so I can say return new A1 and remove this void. So now I have a show which returns an object of class A1. We have a show in class B1 which returns an object of class B1. So look, what is different here is that here in the superclass the show returns an object of type A1, whereas in the subclass B1 it returns an object of type B1. So this is perfectly okay, there is no error in this. Earlier, before Java 5, this used to be an error because it mandated that the return type of both the methods had to be same. So here also you need to add A1, but after Java 5 there is slight modification to this. Now the overriding method can declare a return type which is subclass of the return type of superclass. So if this declares A1, the subclass can have a return type which is a subclass of A1. So I can even return C1 here, which is also a subclass of A1. So the return types of overridden methods can be different. However, they must have a relationship of inheritance, and in the overridden method the return type should be of the superclass, and in the overriding method the return type should be of the subclass. So here also I can say I can take B1 as the return type, and I can say so this is a modification from Java 5. Earlier the return type had to be same in both the overridden and the overriding method, but after Java 5 we can have an option where the overridden method can declare a return type and the overriding method can declare a return type which is not the same as the superclass method, but it can be of a subclass of the return type of superclass method. So this is relates to the runtime polymorphism, now which is very important as far as the Java is concerned. So the main part is that the superclass variable or object, it can refer to the subclass object, and subject to the conditions that it does not apply to private methods because they are not overridden. Static methods it does not apply because they are independent of the object, and this entire show of runtime polymorphism depends upon the type of object. and there is no runtime polymorphism in case of variables.